Today's short. Only going to do two kind of example problems. A is super easy. B is a little bit more. There'll be one kind of like jump we'll have to take. Other than that, pretty straightforward. So our first theorem and our only theorem is the circumscribed angle theorem. I like breaking down these words. So circum, you think of something, it means around. So if you like circumvent something, you go around something. The circumference of a circle is measured like around the outside of the circle. So circumscribed means around or the outside written. So we're writing angles around the outside of our circles. And a circumscribed angle specifically is made up of the two sides of the angles are both tangents. So you can see here are two sides of our angle. Let's do them in orange. These are both tangents, and we have an angle inside of them. They make an angle D, or you could say, be specific, ADB. And the measure of a circumscribed angle is equal to 180 degrees, so half of the circle, minus the measure of whatever central angle it intercepts. So the difference, remember, a central angle, it starts from the center of the circle and it goes to either side. So this here is angle ACB. So we take 180 minus whatever the measure of our central angle is to get our circumscribed angle. And we already see why it's 180, because making a tangent, it's never going to go like, you can't go past like half of the circle. Like that 180 would be right here. To draw two tangents, they wouldn't be able to, they'd have to intersect a lot farther out. So it's 180 minus whatever our central angle is. So I'll do what I did yesterday, kind of leave the theorem up there and write out what we're trying to find. So we're trying to find the value of x is our unknown. So we could say the measure of angle, we could say D, or we could be specific, it was angle ADB, just like in the theorem, going from A to D to B along the outside, is equal to 180 degrees, that's always going to be in there, minus the measure of our central angle that is formed, that our circumscribed angle kind of intercepts. So that's angle ACB. Measure of angle ACB, or you could say BCA, however you want to do it. Now we're at the point where we can just plug in what we know. We know we're trying to find what x is. We know it's 180 degrees minus our central angle is 135 degrees. So 135. And if we do some subtraction, you would get out x is equal to 45. Nice and straightforward. Easy theorem to follow. When we're given the central angle, of course. Next example, it's an inscribed angle, so we have to do kind of like a jump in our kind of logic and connect some things together. So as we start, I just kind of want us to ignore this angle on the outside to start. Ignore the 30 degrees. We're just going to look at the inscribed angle. So we're going to look at angle EJF, which would be our x, right? That's equal to x. And this x, since it's an inscribed angle, we know x is equal to half of the arc that it intercepts. So we're going back to old things. Inscribed angle, it intercepts arc EF. So you could say the measurement of angle EJF is equal to 1/2 of the measure of arc EF. So to go back and look at our theorem above, we need to have a central angle at G, which is, if we could draw, we'll have to draw our own central angle in there, and we'll do that in red. Where we could draw a central angle that looks like this. It goes from E G to F. All right, so I'll label that on the top so we know that, okay, so we now have a central angle in red there. That's angle EGF. And we know that the angle EGF is just equal to the measure of the arc that it intercepts. So again, since it's a central angle, we don't have to do the whole 1/2 piece. So angle EGF, that looks like a 6, so let me change it. EGF is equal to the measure of EF. And to find this angle measurement here, we can use our circumscribed angle theorem. We fill in what we're trying to find. We'll do it here at the bottom now. It would be our circumscribed angle, so angle EHF is equal to 180 degrees minus whatever our central angle is. So that would be the measure of E. I should make sure it's an angle. Sure. Notation is important because it tells you what we're talking about. So I gotta make sure I have my angle symbol in there. Angle EGF. And now we can kind of play a game of plugging in things that we know. We know that angle EGF is going to be the same measurement as the minor arc EF. We also already know that this angle is 30 degrees. So we're going to keep plugging in what we know. So this is 30 degrees. This is 180 minus the measure of angle EGF. The measure now, since we took this 1/2, and it goes from 1/2 from here to here, but this is just a 1-for-1. It isn't scaled by a factor. We can go ahead and plug into here. We can go back and we're kind of combining two theorems at once. This is why this one is a little tricky. we could say it is 1/2 of the measurement of 180 degrees minus our 30 degrees. So we're kind of now combining our two things together, Joop and Joop. So then when we go through, we could say, well, this would be 1/2 of, what is what we do? This would be 150. So then this is equal to 75 degrees. And that's what x is. So x is 75 degrees. Which we could fill in kind of just so we can like have all of our pieces together, and maybe it'll make a little more sense. I know this one is difficult because we're putting things that we did like 3 days ago with new things that we're doing today. But since this is 75, this here, it would be 75 doubled. So we'd get back to 150. And that would mean this central angle here also is going to be the same as the arc that it intercepts. So this is 152. We can go back and see now. Look at the measure of this outside angle should be 180 degrees minus the measure of our central angle. So we're really doing 180 degrees minus 150, which gives us 30. So these are it's one of these problems where you're combining two things together, and there's a lot of roundabout ways that you can go about this. You may see a completely different way to do it. I'm sure there's multiple ways to go through. You could have just solved for x straight away using the theorem, doing some substitution. But this is just one way to approach it. And we're getting more practice with this. A lot of the times on like the homework and stuff, we won't have to combine two formulas at once. It would usually be a one or the other type deal.